Welcome back, physics enthusiasts. I'm Swati, and welcome to my series on mechanics. We are learning vectors. Last video we did some concept and some numericals on scalar vector or dot product. Today we'll do some more numericals and we'll move to vector product. So let's begin with that. So before we do some more numericals, let's understand one more concept on scalar product, that is the projection or components of one vector on another, or components of B vector, let's say B vector on A vector. Okay, so what does it mean? Let's understand that this is your A vector, okay, and this is your B vector, and this is the theta between them. Now it is asking the projection of B or the component of B on A, or you can say along A. So if you ask the component of B, so the component of B here is basically B cos theta, right? Or the projection is also this. So B cos theta is basically the component of B on A along A, or the projection of B along A. So to calculate B cos theta, what we will do, let's say A dot B is equals to AB cos theta. AB cos theta. If you need to calculate this projection of B a component of B, that means they are asking you B cos theta. Okay, so B cos theta is a projection of the component which can be calculated as A dot B over A, magnitude of A. Okay, then you will get what? The projection of B. So this is something important. So always remember that whatever component they are asking along A, so you have to calculate their A dot B, and whatever the vectors be there on which you want to get the projection, get its magnitude here. We'll do one question. Okay, here let's say your A vector is 2i cap minus 3j cap. Okay, find the component of A along I cap plus j cap and I cap minus j cap. So they have asking along this. So what you have to do, you have to take the magnitude of these in the denominator. So first, let's say this is B, I plus j. Okay, so to get the component of A along I plus j, so you have to get what? A dot B over magnitude of B. Okay, whatever the vector it is on which you want to get the component, you have to take its magnitude. So you want to get the component of A along this, we have to take their magnitude, which is we have taken as B. So A dot B is what? 2i cap minus 3j cap and dot product of what? I cap plus j cap, I cap plus j cap, and over magnitude of B, which is 1 square plus 1 square. And just take the magnitude. 2 plus 1 is 2, minus 3 plus 1 is minus 3, and this is 1 plus 1 is 2, root 2. So it's what? Minus 1 by root 2. And similarly, you can calculate the component along I minus j. You have to put I minus j just here, and the magnitude will remain same. Dot I minus j, and the magnitude would be 1 square, and minus 1 square is 1 square. So 2 minus 1 minus is plus 3 over root 2, that is 5 by root 2. Let's take this to be C, I minus j. Okay. So just remember, whatever the component you want, what you have to do, you have to take the dot product of both and you have to divide the magnitude with the vector along which you need the component. So they can ask the component of a vector or the projection of vector. It is one and the same thing. So this is something important. Okay. Okay. Let's do some more questions and then we'll move to what? Vector product. The question is, if the sum of two unit vectors is a unit vector, find the magnitude of their difference. You can learn the standard result also, but I'm showing you the proof. Find the magnitude of their difference. Okay. So what you need to do, again, squaring thing. Let's say if they are giving two unit vectors, is again a unit vector. So let's take three units vector, n1, n2, n3. N is basically the notation which we use for unit vector. But you can say n is equals to n1 plus n2. Okay, the sum of two unit vector is equals to a unit vector. All n, n1 and n2 are what? Unit vectors. Okay, unit vectors. Now, always do squaring. So here also you have to do the squaring on both the sides. So this is your n square and this is your n1 plus n2 square. And if it is n1 plus n2 square, then you have to take the dot product of n1 plus n2, dot product of n1 plus n2. If you take the dot product of two equal vectors or a vector with itself, its magnitude square. We have already discussed that the angle is 0 here. You can check in a previous video. So this n1 dot n1, I'm writing n1 square. Then plus n1 dot n2 plus n2 dot n1 plus n2 square plus n2 square. Actually, it is n2 dot n2, but n2 dot n2 is n2 magnitude whole square. Now this n1 and n2 are all unit vectors, so their magnitude is 1. So this is 1. This is also equals to 1, and n1 plus n1 dot n2 or n2 dot n1 can be written as twice of n1 and n2, because this can be written as n1 dot n2. This is the commutative law. A dot b is equals to b dot a. Again, we have discussed that. So it's simply 2 n1 dot n2, and this is plus 1. Okay. So now this is 1. You can cancel these two. Let's take minus 1 to be here. Then it's 2. n1 and n2 can be written as magnitude of n1, magnitude of n2, and cos theta. Okay. Magnitude of n1, magnitude of n2 again is 1. So simply your cos theta is minus 1 by 2, which is 120 degree. Let's check it minus 1 by 2. Now what they have asked you find their difference. n1 minus n2. Okay. So for n1 minus n2, let's take another vector, which is C vector. You can't take this as a unit vector because they didn't ask about that. They just asked what should be n1 minus n2. Again, square both the sides, C square, then n1 minus n2, which is difference of their vector. So n1 minus n2 dot product, I'm squaring both the side. So this become C square only. This become n1 minus n2 dot n1 minus n2. n1 minus n2 dot product of n1 minus n2. Now just take n1 dot n1. n1 dot n1 is n1 square. I'm writing it directly. Again, minus n2 n1. Then minus n1 n2 and then plus n2 square. It's simply multiplication rule. We have to calculate the c here, okay, which is the difference of these two unit vector. So this is 1. This can be written as twice of magnitude of n1, magnitude of n2 cos theta, minus 2 n1 dot n2, and here the dot is, okay, n1 n2 cos theta plus 1. Okay, so now 1 plus 1 is 2, then minus 2. This n1 n2 has a magnitude of 1 because they're unit vector. Cos theta is minus 1 by 2. Since the theta is the angle between n1 and n2, this theta is also the angle between n1 and n2. So we can use its value here, minus half, and then you can cancel 2, and minus and minus become plus 1. 2 plus 1 is 3, and that c vector, that c, which is n1 minus n2 difference, comes out to be root 3. So you can remember that if the sum of two unit vectors is equals to unit vector, then the magnitude of their difference is root 3. If you are in competitive, you can use this. Okay, so these are the major things of scalar product which we have discussed in our last 3 classes. And if there are some more numericals that we will do in the last, where we combinedly solve the numericals from all the topic. But for now, let's move to what? Vector product. Okay, so now what is vector product? Vector product or cross product. Cross is because of the symbol. Okay, so let's take first. The thing is, in this, it is like two vectors. A vector have a vector product or the cross product with B vector, and because of this cross, you have to write as a cross product, gives you another vector. Okay, so it is called vector product because the result is a vector called vector product, as you get a vector here, and next y cross because you use cross as a symbol. Use cross as a symbol. So these two reasons of the name. Now for A cross B is equals to C vector, and the thing is these two have direction and the C also have some direction. Okay, so here you have to deal with the magnitude of C and the direction of C as well. So the basic A cross B, what is its meaning? So its physical meaning is that you have a vector A here and you have a vector B there. Now A is rotated towards B or B is rotated towards A, and you given another vector which is a C vector. Okay, so in scalar product it is like a projection, and in vector product it is more like a rotation, that A cross B is A is moving towards B and B cross is B is moving towards A. It has that physical sense. But mathematically Mathematically, this A cross B can be written as what? A cross B is equals to magnitude of A, magnitude of B with sine theta. And since the answer is a vector, so this is a unit vector n cap, which is the direction of this C vector. So this is its mathematical expression. But what it is exactly, how you can remember it visually, and what are the other things, we are going to discuss in this vector product lecture. Okay, so now here you have to remember certain things, that this A plus B, the vector whose you are taking cross product, should be in a plane. Should be in a plane, in a single plane. Should be in one plane. And that means xy plane, yz plane, or zx plane. Okay, xy or yz or zx plane, anything. And this C vector then should be perpendicular to that plane. Okay, if A and B are in xy plane, then C should be in z plane. If they yz, then x, zx, then y, like that. So C should be in a plane perpendicular to A and B. In a plane perpendicular to the A cross B plane. B plane. Okay. So to determine the direction, you can use, okay, to determine determine the direction of C vector, what you need to do? Use right hand thumb rule. You already know about it if you have learned in grade 10. Use right hand thumb rule. Now, here is an interesting thing. Wherever you will see the vector product, means in any formula or any way you are using this vector product, use right hand thumb rule to determine the direction of that physical quantity. And what does that right hand thumb rule says? Just extend your fingers in the direction of a vector and curl in the direction of other vector. That is, if it is A cross B, put your fingers in the direction of A, then curl it towards B, and wherever your thumb is pointing gives you the direction of C vector. Okay, so whenever you use in any physical thing, just place your fingers in that physical quantity, curl towards another, and your thumb gives you the direction of the resultant physical quantity. So extend your fingers of right hand. Extend the fingers of right hand in the direction of A vector. I am writing in terms of that A cross B only. In the direction of A vector, and curl towards B vector, and curl in the direction of B vector, and curl in the direction of B vector, and then the extended thumb gives you the direction of C vector. Then the extended thumb gives the direction of C vector. Okay, it is like that. But there is one more method through which you calculate the direction of this using ijk cap, which we will learn. So this n cap basically is what? A unit vector perpendicular to the plane of A and B, which gives the direction of C vector. So a unit vector, a unit vector perpendicular a unit vector perpendicular to the plane of A cross B, A cross B, to give the direction of C vector. To give the direction of C vector. Okay. So that is the basic thing of vector product, which is the vector gives you a vector thing, and it can be written as AB sine theta with n cap. And to determine the direction of C, you can use right hand thumb rule. Just curl the fingers in the direction of other vector. Put the fingers, extend the fingers in the direction of one vector and curl towards the other vector, and the extended thumb gives you the direction of the resultant vector. And the two vectors A and B should be in the same plane, and the resultant would be in a plane which is perpendicular to A and B. So this is a basic introduction of C vector product. So this is much for today's video. Tomorrow we're going to learn this vector product more deeply. So what is this vector product and what is properties, how you use them, how to calculate this A cross B like we did earlier. So we'll meet you in the next video. Until then, do like, share, subscribe and comment below all your question, queries or any feedback or anything, and we'll meet you tomorrow.